Quantum mechanics describes the properties of light, atoms, and the even smaller particles inside atoms, like electrons and protons. On these tiny scales, we observe strange effects that contradict our everyday experience. And we are beginning to harness these effects to build technologies that seemed impossible before. I went to the 2016 National Quantum Technologies Showcase in London to find out about the latest quantum leaps in quantum technology.
Today, we've got the second showcase for this large quantum technology program that the government funded with 270 million and which started in 2014. The whole program is actually about taking the fantastic international quality quantum science which the UK has, pulling that out of the lab into industry and in fact creating in the UK a brand new industry based around quantum engineering, making use of quantum science but in a practical engineering background.
That was Professor David Delpy, chair of the programme. But what are these practical applications? Well, the showcase was split into 4 main fields: atomic clocks, secure encryption, microscopy, and, what I found especially exciting, gravity sensors. Sounds a bit sci-fi, so how do they work? The heavier an object, the stronger its gravitational pull. Anything that is buried underneath your feet changes the strong gravitational pull of the Earth ever so slightly. And because a quantum system is so fragile, it is affected by these tiny changes. What can we use it for? David explains.
Well, first of all, it can tell you whether the ground underneath you has a sinkhole appearing in it. It will tell you whether the water table is rising or falling, whether there are minerals there, what the density difference is. It can also, of course, tell you whether there are underground pipes, whether there are gas mains, so underground services, which in the UK we've got an awful lot of, but we don't have, to be honest, accurate maps of where they are. We spend almost a third of the costs of the holes that we dig in the country digging holes in the wrong place. So there's a fantastic application there if we can detect what lies underneath our feet.
Sounds like gravity sensors will have to scan large areas for many of these applications. But until recently, they weren't even portable. I was intrigued to find a really big drone next to the prototypes of gravity sensors. PhD student Andrew Lamb from the University of Birmingham told me what it was doing there.
We're looking to develop a lot of our technology from being lab-based and sort of being ground-based to something that is potentially more portable. So in front of you, you've got not just the drone, you have a number of our systems. We have some of our lightweight prototypes where we've taken traditionally large lab-based systems, put them into very compact, lightweight structures. And we're moving towards putting some of these onto drones. The payload itself is only about 6 kilos.
Miniaturization is really key to get gravity sensors off the ground, in the most literal sense of the word. But while gravity sensors may soon be used for large-scale projects, what can quantum technology do for me personally? Well, this is where data encryption comes in. Sir Peter Knight from Imperial College London explains how the laws of quantum physics could help to make my data safe.
If you try to copy a quantum system, you only get partial information, and that partial information just screws everything up so that a legal recipient says, there's somebody else on the line. So if I can encode information in individual quantum systems, because you can't copy that information, any attempt to intercept it reveals themselves. And that's where the security comes from.
What could quantum secure communication look like in a practical sense? Dr. David Lowndes from the University of Bristol took me through the process of using a quantum secure bank card, one that we may be using in the not so distant future.
Basically what you would do is you have this little card, and it's got some LEDs which make single photons.
And these single photons, these light particles, hold the secret for the encryption. They oscillate in a certain orientation in space, their so-called polarization. Just like we encode information in words and letters, our computers use the language of 0 and 1, and this bank card uses the polarization of a photon to encode information, as simple as that. But how do I write information into this card? Let's try this out. David plugs my special bank card into an encoder which looks pretty much like a standard computer.
And that would send the photons out into this bigger system which would do all the processing. You can then slip it out, And what's happened there between the card and this box, they've generated some key between them. This is an encryption key that you can then use later on for maybe encrypting your banking information, or if you're doing some shopping on the internet. If you measure a quantum state, it irreparably changes it. So this gives you some way of knowing whether somebody has listened in on your transaction.
Brilliant, isn't it? From gravity sensors to encryption, David Delpy, chair of the program, is excited about the prospects of quantum technology.
What you've got through, in effect, manipulating individual ions and atoms at a quantum mechanical level is a range of sensing techniques which far surpass everything that we've previously been able to do.
Universities and industry working together to turn quantum science into innovative products. That was me, Kirsten Göpfrich, reporting from the 2016 National Quantum Technology Showcase.